This is a regular size Benchy, but for some reason it looks extremely small on this printer. Welcome to my Tech One, to another 3D printer review video, and this giant box is sent to me by the Sovol company in exchange for the review, but there is no additional payment, so this is not a sponsored video by the Sovol. This channel has its own sponsor, and that's the Polymaker. Few specifications about this printer. The build volume, I think, is the most important. It is 500 mm in X, Y and Z direction. This is fast CoreXY printer based on Voron. It uses a Clipper operating system, and the maximum speed is 700 mm per second. It has a 4.3-inch touchscreen, camera, and it is fully open source. Quick eddy current leveling. This is important when we see how fast is the bed leveling, because it is important for this large build volume. Under the bed it has an 8 mm thick aluminum plate, which is quite big, and it is heated up by 1300 watt power. It has auxiliary feeder, which is used not only for the smooth feeding, but also for the tangle detection, and we can use it as a filament runout sensor too. The maximum temperature on the nozzle originally planned was 350 degrees Celsius, but later that changed, so now officially it is 300 degrees Celsius. Currently I'm on my workplace where we have several projects where we need this big build volume. Few things which I want to test, and these are very important things for me. Bed leveling test, printing the full surface almost. It must be reliable with PETG. Now Sovol sent me a lot of filaments, but only PLA, mostly silk PLA, and later they sent me some PETG two spools. It is very important that filament runout sensor works correctly, because with this big volume probably you will run out from the filament quite often, and this must work perfectly. And how fast is the bed heating? This is not so important for large, big, long time printing projects, but even then it is good to know how much time it needs to heat up to 70 or 80 degrees Celsius, which I use for the PETG. And how equal is the heating, because I want to use the whole area of this surface, and I don't want to use only the center, because only there, let's say, it has 70 degrees Celsius, and closer to the edge it has only 50, for example. So it will be a thermal camera test too. So let's see what's in a box, and probably I will need a bigger workbench too, or maybe I will start with assembling on the floor. This is really a huge box. Here we have the instructions for the assembling, user manual. Nice to see that we have a filament on the spool, and not only 10 meter sample filament, white PLA. A lot of hidden parts. Don't forget to take out everything. Wow, this base is huge. I already measured it. It requires 72 by 72 centimeters on the desk. So before the buying, check if you have enough space on your workbench. This was the content of the toolbox, and my favorite things are these screwdrivers. We have some spare parts, tweezers, glue stick, USB card, user manual, and the screws are labeled. For each step we have a separate bag. It's time for the assembling, but I don't want to create a detailed assembling video. I can see that most of the viewers skip that part. I will just show main steps. So I'm starting with these vertical elements, and they are labeled so we cannot mix the corners. It's a little bit tricky. We have to slide it partly from the bottom. And step 2 bolts goes from the top. Next important step is installing the top frame. 2 screws from the top for each corner. And now installing the AB gantry, how they call it, but it is not so easy because the extruder is not mounted on the holder like on the picture. Installing the extruder, but first I have to take off this cover, which is attached with the magnets. Time for some cable management with this drag chain. And now installing the screen, and this is the screen which arrived in the box with the printer. And a few weeks later I got this bigger one, HDMI screen. Theoretically you can buy this separately, but the original screen is this one, so I will start using with this. Installation of the screen is finished. Ah yes. Only now the installation is finished. One more thing I got separately are 0.6 and 0.8 mm nozzles. By default it will arrive with 0.4 mm. These are looks like some kind of hardened steel nozzles. And this is the wrench for them. Installing the spool holder. Auxiliary feed mechanism. And now installing these corner brackets. They will really help with the rigidity of the whole frame. And now the hardest part, connecting the stepper motors. Actually, it is not as difficult as I thought at the beginning. Okay, easier than I thought. And now connecting the cables. They are labeled, so it is very easy to find their spot. I just turned it on a few seconds ago, and before I continue I want to mention that unfortunately I don't have a quiet standby position. Some fan inside is extremely loud. Okay, English, next. And now it offers me to do this calibration in 3 steps, which includes the bed mesh calibration and vibration calibration, which is the input shaping. Okay. Leveling the gantry. Wow, this is the bed leveling. Really fast. And now it starts with vibration compensation, which is the input shaping. Saving the results, and it will be ready for printing. About these lights, it is good to have them, but they're on this height and the printing is down here, so basically it is just a decoration in this case. More useful would be lights maybe here and here on the other side. These are PLA filaments which I got in the box. These are Silk Magic and Silk Rainbow. I think these change the color in the cross section, and these after some meters along the filament. And now inserting the filament, I'm just following the instructions on the screen. After inserting the filament into the auxiliary feeder, it will be loaded completely onto the extruder. Let's see that Benchy prepared by the Sovol. The bed heat up time will be almost longer than the printing of the Benchy. The start is good, but this desk is shaking a lot. But the frame rigidity should protect the printing from these outer vibrations. The active printing time was really only 10 minutes. The bed adhesion is good until it's hot. A big surface heats up slowly, but also the cooling is very slow too, because I cannot remove it until it's hot. Okay. Not bad for the 10-minute Benchy. Here I can see that it's a little bit over melted. I will slice my own G-code and then I will reprint this Benchy. Sovol offers a profile for the Orca slicer, and since this is one of my favorite G-code creators, I use this software. The bed heat up time to 65 degrees Celsius was approximately 4.5 minutes. And after 8.5 minutes it starts with the printing. Compared to this big bed, this is ridiculously small. It's finished. I will compare it later because I cannot remove it until the bed is hot. The adhesion is great. Okay. The improvement is quite obvious. Here the most critical part was here because I think it didn't have enough part cooling for this small area, and on this one it came out perfectly. Only one issue I have with this Benchy, and that's this small ghosting here. Next printing will be this owl. The height is 360 mm. I wanted to print a 400 mm version, but it requires more than 1 kg of the PLA, and I'm not sure how this filament runout setup works at this moment. And this is the auto leveling, super fast. Only on the area where the printing will be placed. With a smaller printer, this could be even the bed leveling test, but in this case, it uses less than 20% of the area. Well, it's the end of my work day and I have to go home. And I hope I can trust to this machine because everything will be printed overnight without any supervision. It's the next day and let's see if we have an owl or a spaghetti monster. Ho ho ho! Printed in 13.5 hours. Oh, it's already removable. Huge. And this is the amount of the filament which left on the spool from 1 kilogram. The quality is great. But this noise is completely unnecessary. I mean, this printing was finished maybe 10 hours ago and it's still very loud, and those fans are still working on full power inside. Let's give it 1 hour break and then I will prepare the next printing. Wow, it's quiet now. This quiet should be in a standby position too. Next will be the bed leveling test, but very important that I have to clean the bed. These are my fingerprints and it has to be clean. With so big area, even the cleaning takes much more time. Well, this time it has to scan the whole area, auto leveling. The start is okay. Even this simple test will take 2 hours. 1 more minute and it will be finished. And this first layer looks okay, but I will see how connected are these lines when I remove this printing. More or less it is quite constant. I can see on some places the layer lines are not completely connected, but with the second layer this will be completely fine printing. I still have some silk filament on this spool, but I want to try some matte filament too. This is in grey color. Extrude. I can see the filament is extruded on the other side. And this will be a little bit more than 11-hour printing. First layer looks okay so far. At the end of my work day I have to go home, so another printing which will be finished overnight. But this time I'm not too happy about this. This infill doesn't look too healthy. Outer walls which are printed slower are completely okay, but this fastly printed infill, not really. Oh boy, how will I sleep tonight? I slowed down the printing to 80% and now this infill starts to look okay. Now I can sleep better. This filament don't really like high speeds, so maybe this is the reason, but I hope it will be okay now. It's the next day again, and the standby position of the printer I can hear even through the door. And the printing was successful. Is it removed already? Yes. Whoa. This one is huge too. Not exactly real size. This is the amount left on the spool, and the printing time was 15 hours. I have enough filament for this test. I want to check my theory. Is really the maximum flow rate of this filament much higher compared to this one? This flow rate test will be from 5 up to 20 cubic millimeters per second. And the maximum height is 32 millimeters. If I have to stop it earlier, from this I can calculate the max value. It was finished completely. I will switch the filament and then I will analyze them side by side. I don't want to wait half hours until it cools down. I'm printing with exactly the same G code. It's finished few seconds ago and it looks completely okay even on maximal height. Side by side two materials, and even if this one is finished completely, I can see some signs of the under extrusion. Until the silk filament is completely fine even at the end. So yes, there is a difference between PLA and PLA. I know I should do this test on higher flow rates too. This was the default in Orca Slicer, and definitely you should test the maximum possibility of filaments you are using regularly on your printer. It's time to test the filament runout sensor. I will cut the filament here and then switch to this PLA Silk Rainbow. It's just a simple box from the PLA. The first layer is okay, but this test is about something else. Blue light, filament loading not smooth. Actually it ran out from the filament. Maybe it knows that there is almost 1 meter filament inside the Teflon tube before it stops. It stopped now and end of the filament is somewhere here. Let's see if I can pull it out. Extrude. And I can see it on the other side. Now it's a good habit to pay attention to the nozzle, and if there is any filament from the oozing, remove it. Resume button was here only, it was out of the frame. The filament change was successful without any problems at approximately 5 mm height, so I will analyze it later, but I will let this box to be finished. Let's take a closer look. Except this small string from the oozing and the color, there is no sign of the transition, it's perfectly smooth. Okay. So this was the magic filament. We changed the color from different sides, and this is the rainbow. We changed the color after a few meters, but for this we have to print something bigger. This will be a marble run. 4 years ago when I saw this model for the first time, I wanted to print it, but when I saw only for the track it required almost 2 days on those printers, I gave up. And now this printing will be finished in 8 hours. And this printing requires 82 meters. This means at the end I can calculate after how many meters it changed the color. The printing is at 42%. The progress is good without any problems, but the rest of the printings will be finished without my supervision. I have to go home now. Hopefully everything will be okay in the morning too. It is always so exciting in the morning to see if this log printing is successful or not. And everything is okay this time too. And no supports. This is so nice design. Few more elements I have to print. And it looks like we have the color transitions after every 12 meters. So this means you have to print something really big to see this effect. Let's move to the PETG, and I will start with the black color. I need adapter for this HDMI screen which I got from them. PETG is very important for me. Currently I am building this experimental vinegar fermenter. This is made from the transparent PETG, and if this will work, then with this printer I can scale this up to much bigger volume. Everything is okay so far. The print temperature is 255 degrees Celsius and 80 on the bed. This will be a little bit more than 1 hour printing. The holder is on, so let's switch the screen because this is quite buggy and has limitations. For example, we cannot reach those macros, and this should be a real clipper screen. The housing of this new screen is also 3D printed, so I don't really understand why they didn't use the correct dimensions. Maybe just an early bird product. We have enough space below the printer. So it is not really the size, but the functionality. And now switching to the white PETG. I can see the filament is changed. Well, it's a very interesting start. Almost like a bed level test, if it would be bigger. This is that offset board for Carrera Air milling machine. We can buy this from the MDF, but it is good to know that I can print one. Maybe I want to add some additional holders or something like that. And PLA is not good for this because it may deform under the heat of the vise. ABS is not good because it will shrink and those holes will be not accurate. So PETG is basically the best material for this. It's finished perfectly straight without any warping. Now the top surface could be a little bit better. And I bring my noise meter here. 55 decibels for the standby position noise, this is extremely loud. Just one more test. I have in progress testing PETG filaments, and if this will work on this open printer, then this may be the strongest filament which we can print with this machine. It's dried, but this will be a long printing, and I would like to print from this dry box. I'm afraid a little bit the friction may be too big in this 1 meter long Teflon tube. It would be good to have solution to place some holder here, but officially we don't have a solution to avoid this feeder currently. Yes, we can modify the configuration file, but it would be good to have some kind of official solution to this. Screen cables are in the way, and this will be too much friction anyway. I will take it out. "98 degrees in approximately 10 minutes. This is just a quick printing test on the maximal temperatures, possibilities of this printer. I want to check the bed adhesion, but later I'll print something bigger. After 10 minutes of printing, the bed is set to 100 degrees Celsius, and mostly it is in the center, maybe even more, but in the corner it is 90 degrees Celsius approximately. The printing is finished, bed adhesion check, and it's okay until it's hot, but I don't want to wait half hours until it cools down. And when the bed cools down. Okay. Now I didn't really like those 100 degrees Celsius. I can see some marks from the skirt especially, it was very hard to remove it, so for the next printing I will reduce it to 90 degrees Celsius. This will be a corner bracket for 1 meter long alloy extrusion, and again I have to go home and I can see that the corners are down. The printing is at 35%. I use the mouse ears here in the corners, it should be okay, and I know, see you in the morning. Good morning, and interesting, I can see it is not finished. Filament sensor error, extruder clog. Wow, this means all night this is 300 degrees Celsius and this 95 actually. But let's try to fix this, or why not, continue. It's really hard to clean it, I have to do it under this angle. Unfortunately this is not a nozzle clog, it's stacked higher, and this means one thing. What a bad ending for the video. Pity, because for the fairing this is really rigid, and maybe I will use it as it is now. Yes, disadvantage of these big printings, if it fails then you lost a lot of time and material. It's stuck approximately on this height. This means somewhere here, and also this means that this is some kind of heat creep, not clog in the nozzle, because the filament was melted in this cold zone. Let me show you quickly. I remove the nozzle, and with 2 bolts from the side and 1 from the front I can remove this hot end, and from the bottom I can push it until here, and same from the top, maybe 10 millimeters down. This means I have some material stuck inside. This is the typical heat creep. Now I admit, afternoon without ventilation in this laboratory knows to be very hot, but even then imagine if this printing would be inside the enclosure. And I'm very late with the video, so no more printings, it's time for the conclusions. How about the hot end? On my workplace I don't have a heat gun, so I try to repair it by removing the fan and heat up the hot end. In this case the heat goes up to the cold zone too. And I was almost successful, but I used a lot of force, and since the wires are still connected to the extruder, accidentally I pull out the thermistor wires. This means the hot end needs a replacement now. How about the printer itself? I really like this Voron style open source huge volume printer, whole new possibilities for me. But there are a few facts. Almost for every printing where you want to use this printer and not some standard size, you will need more than 1 kilogram spool and more than 1 day printing with 0.4 mm nozzle. Of course we have bigger spools, 3 kilograms, 5 kilograms, the filament sensor works fine. About print time, Maybe the standard nozzle with this printer should be 0.6 millimeters instead of 0.4. With this we lost some details, but for example this, it will be perfectly fine with 0.6, maybe even 0.8 millimeter nozzle, but of course we have to measure the maximum flow rate in this case. When I will replace my hot end, probably I do one more video with 0.6 millimeter nozzle to see the possibilities of this printer. I'm very confused with these screens. The standard screen is just a little bit smaller, but it's very buggy. It still has some Chinese words in English version. We cannot reach those macros. I don't think the clipper screen is much more expensive, or maybe it should be standard, but with this and now we have those wires on the side of the printer which sticks out. And why it is not equipped with the size which can fit on the place of the standard screen. Maybe just an early bird version, I'm not sure. And this noise I measured several times. And instead by position it is also very loud, but we can hear it during the printing, and not only the noise but that high frequency, and especially during fixing the hot end, it drives me crazy, that high frequency sound next to my ear, maybe, I don't know, 200 or 300 millimeters. The print quality is acceptable, but I think there is one important improvement that you should do here, and that's the thickness of the timing belt. I can see that even smaller printers now arise with 10mm belts, and this is big length. And you know, these, even if they are reinforced timing belts, they are flexible a little bit, very minimally, let's say 0.1% or something like that. And if it is longer, then that percentage is longer in millimeters. And with this, definitely they should improve the quality. And I think this size should arrive with at least 10mm timing belts. Auxiliary feeder, it is good to have one. My friend Gergo Print 3D, he noticed an error in his unit. One ball bearing is missing on the shaft. I will place a link to his video down in the description. It would be good to have some kind of official method to avoid this. In case I want to place a spool holder above the printer, then I don't want to use the auxiliary feeder. It is nice to have one, but it would be good to have an option to avoid it. The friction inside this 1 meter long Teflon tube is quite big. Maybe they could use a little bit bigger outer diameter here. And I think these macros should be improved for unloading and unloading filaments. And I have the feeling that this printer is almost finished, but not 100%. Maybe I will create one more video with 0.6mm nozzle, but in that case definitely I will reprint this corner bracket because I really need one with this size. And I would like to give you a suggestion for a YouTube channel. There are smaller YouTube channels dedicated to mostly Sovol printers and their upgrades, only it is hard to find them. One of them is my friend Gergo Print 3D. I will place a link down in the description, and even if only one video you want to watch from him, I would suggest you the upgrades of the Sovol SV08 Max. And as I mentioned, this is my experience with Sovol SV08 Max, huge printer with great possibilities. I think in the future it is great for the upgrades because soon we have those index tools. I saw a video where they used 0 with the 4 tools. Imagine how many tools can fit on Sovol SV08 Max. Thank you for watching this very long video, and I wish you happy printing.